can see what I'm doing.
Okay.
I believe you can see my screen. Can you see the screen?
Yes, I can.
Okay. Can you see your phone or your laptop?
My phone, my phone.
Okay. I think I saved this here. Imagine. Imagine. So, listen. Um, I'm looking for a material. Okay, I think I have it. Let me even move it inside here. So, in here, let me even share through my. Let me go to my so present. Hold on. So let me share through my Microsoft Teams. Okay. I have the my pictures. Where is it? Okay. So, hold on. So I'm just doing this as to be flexible for me to just I don't want to. So can you see this? Can you see this here?
No, it's not clear.
Okay. 100%. How about like this? Do I equate it again?
Yes, please.
Is it better like this?
If you can still increase it a little bit.
Okay. What about
Yes, but yes.
so first of all we are going to start from derivative. We are going to start from derivative. So
Okay.
I believe in our first year calculus we will do something like introduction to calculus and we will we did in differentiation, we talked about chain rule, we talked about product rule, we talked about quotient rule and stuff like that, right? So I believe you still remember all of those. Do we still remember all of those?
Yes.
Okay, but in this case, in mathematical methods, so let me use in mathematical methods in Unilag. So let me say mathematical method in Unilag. So
Okay.
you are not expected to, if you are given a problem, a differentiation problem in math method, you are not expected to use the product and quotient rule. Though you are going to use it, but not ideally. Not ideally, you are not just use your product rule and quotient rule directly. So you are given a differentiation problem in math method. Yeah, they won't give you a problem whereby you just use a product rule and so you can have a problem whereby you can actually use product rule and quotient rule directly, but it won't be so direct. Look at this example. You have y to be x is per x. Now, normally you cannot use product rule, you cannot use quotient rule to differentiate this thing, but you can have a basic idea of what you want to do, but in this case it's not even direct. So how do we do this? This is not a product, this is not a quotient. Now this idea comes in. We are going to take the natural log now, which is called ln. So so let me go to my whiteboard marker. Let me go to my whiteboard marker. I believe I can still come back to this place. So let me go back to my whiteboard marker. You are expected to do something like, now, if you are given, so this, I just finished the class, that's why you have to do this. So if I'm given this case scenario, you have y to be ln, sorry, not ln. I have y to be x raised by x. What am I writing? So this x is per x. Now, if you are given something like this, say y is equal to ln f of x. That's ln into bracket, say f of x, where f of x can be anything. It's a function of x, can be any function of x. It can be exponential, it can be trigonometry, anything. Now, the derivative of this y, so if we want to differentiate a ln something, any ln, natural log. Don't forget that ln is what? It's same thing as log to base e. You used to remember that. Log to base e. So ln is the same as log to base e. Well, in this case scenario, if you are given log, if they put log and not ln, just assume that it's to be ln. So if you are given a differential problem in mass method and they put log instead of ln, so just take it as it's the same thing as ln. Are you with me? So now,
Yes.
so dy dx, which is the derivative, will now be equals to, now if you want to differentiate a ln function, your derivative is going to be, first of all, differentiate what is inside the ln. And what is inside the ln? F of x. So literally what we call, when we want to differentiate f of x, we call it f prime of x. So the derivative of f of x is f prime of x, like this, in this manner. So derivative of ln f of x is now f prime of x all over f of x. So what does this mean? It means differentiate what is inside the bracket all over what is inside the bracket. So that's the derivative of ln. Do we grab that?
Yes.
So for example, if I want to differentiate ln 2x like this, it means differentiate 2x. What's the derivative of 2x? What's the derivative of 2x? Tell me.
2.
2. Then all over the argument of ln itself, which is what? 2x. Then 2 is going to cancel 2. Then you're going to have what we call 1 all over x. Now, okay, let's move on to our file again. Let me move to my file again and try to open it. So let me increase this by 200%. So we cannot find the derivative of this x is by x directly. So what we have to do is, okay, take ln of both sides. So why are we trying to take ln? Now, if I take ln of both sides, so whenever you're given a differentiation problem in math method, so what should come to your head is that take ln of both sides, take ln of both sides. That's the first thing that should even come to your head, because you won't have a problem in math method whereby you won't take ln when it comes to differentiation. So take ln of both sides. Then after taking ln of both sides, you can see I added ln to y, then I added ln to x by x. So what's going to happen? If you have ln x by x, now literally the power is going to come back to the back of the log function. So if you have log a raised by b, it's same as b log a. So ln x by x becomes x ln x, as you can see here. Are you following?
Yes.
So now, since you are able to do this, to achieve this, so what happens? What happens next? The next thing is now, okay, let's now try to differentiate. I think we'll be able to break this down to become something like a product. So we have x times ln x, right?
Yes.
So this is becoming more simpler. So now we can differentiate. Now, what's the derivative of ln y? First of all, we understood that, okay, if I want to differentiate ln something, first of all, I'll differentiate that thing, then all over that thing itself. So differentiate y, like what, like that's 1 all over y. But since you are differentiating y, you're going to put dy dx here.
Yes.
Then equals to, now this one is a product, so you are going to use what we call the product rule. So if I'm using a product rule on this, and product rule states that if y is equal to u times v, dy dx is u times dv dx, abi, plus v times dv dx. Is that not it?
Yeah.
So I have u, so my u is going to be x here, and my v is going to be ln x. So I have u, which is x, times dv dx, which means differentiate ln x, that's 1 over x, right? Plus v, my v is ln x. Now differentiate u, which is x, that's 1. So 1 times ln x. So you have x times ln x. X is going to cancel x. So I have 1 times 1, which is 1 I have here, plus 1 times ln x, I have it to be ln x here. This left hand side still remains the same. Are we following? So, but then, what do I need to find? I need to find y dx. So it means this 1 over y is not supposed to be here. So how do I get rid of it? I can multiply both sides by y so that this one goes up here, right?
Yeah.
So y times this becomes the y dx. Then y times this becomes y times 1 plus ln x. Now, literally, in your exam, you are going to find your results in this format. If it's an objective, they are going to they will most likely leave it in this format, but you are not supposed to have it in this form. Why? Because I'm differentiating values to x. I'm not supposed to have anything that is y here at all. But in objective, this is how they are going to leave their answer. They are going to leave it in this when they get to this stage. So they won't substitute for y. But your final answer should be, first of all, what is y? Y is what? X is per x. Have you now? So my dy dx now will be x is per x times 1 plus the next. So I will just substitute for my y. I think that part is well understood, right?
When you said it's going to multiply y, because something like that, I didn't get that part.
When I said,
That you're going to cross multiply y or something like that, I didn't get that part.
okay, so let me show you here. I have this. I think this is what I have in that part. Yeah, let me show you here. So I have, let me erase this guy. So I have, I have 1 over y. And over y dy dx to be equals to 1 plus ln x. Is that not so?
Yeah.
So now, what I need is dy dx. I don't need 1 over y dy dx. So I have to multiply both sides by y to get rid of this guy. It means anything I do to the left, I must do to the y. So why am I multiplying by y? So that I can get rid of this guy that's at the bottom, which is y here. So I'll do y times 1 over y dy dx is equals to y times 1 plus, they are together, so I'll just put bracket here, times the next, so that this y cancels this y. So I'll have 1 times what? Dy dx, which is what? Dy over dx to be equals to y into bracket what? 1 plus the next. Do you get that part now? Is it well understood now? Okay, so let me go up this part again. I think that's clear. So let's go back to our file. So let me increase this. Now, look at this next question here. I have y to be ln x all raised by x. Now, this is different from ln x raised by x. This is ln x in brackets, then raised by x. Then plus sine x in brackets, raised by sine x. Now, it's becoming really difficult to take ln of both sides now. Now, so let me write that in this on the blackboard, on the whiteboard marker, so that you can get what I'm talking about. I don't want to be skipping and going back. Let me use the web. Oh, web. I'll use another whiteboard marker to the web, because the way I'm going on and off, it's slowing me down. Don't mind this thing is too. I might say another thing entirely on this page. So I have two accounts sign in. This is another account entirely. So don't just mind that part first. If you want to do Daska, I can tell you what Daska is anyways. So I have, so this is the web version. I'm using the app for this class. Maybe answer me now. Okay, so good. Can I tell you just to move this guy? Okay. So I have y to be what is it? Ln x. I think x by x, right? Then you have plus sine x is power sine x. Like this. Now it becomes difficult. It becomes difficult to take ln of both sides from here. If I take ln of both sides, this is how it's going to look like. We're going to have ln y is equals to ln, then into brackets, say ln x raised by x plus sine x raised by sine x, like this. Sorry, I do like this. Sine x, then close the bracket. This is not going to make any sense. It's not going to make any sense because it will simplify this problem in any way. It can only be simplified, but if these two expressions are joined by maybe multiplication or division, because you only have you only have that ln AB to be equal to what? Ln A plus ln B, and you have ln A over B to be equal to ln A minus ln B. So having this kind of expression doesn't help in any way, since it is plus. If it is minus 2, but if it is multiplication or division, then taking it directly would have helped. But this way, it's not going to help. So what are we going to do? Now, the beautiful thing about differential is that we can, if I have y to be equal to a function of x, f of x plus, say, g of x. Differentiation is a linear operator. So what do I mean by that? So it means dy dx, if I want to take the derivative, dy dx is actually equals to f prime of x plus g prime of x. What is this in essence? It means the derivative of y is the derivative of f of x and the derivative plus the derivative of g of x. That is, differentiate f of x is equal to x plus differentiate g of x is equal to what? Is equal to x. So it means that I can take the derivative of this and this separately, then add them together. Are you with me?
Yeah.
So what we will just do is that, okay, we now differentiate them separately. So we will now say, okay, no wahala now, you cannot take name. Yeah, say let p to be, p is a function of x anyways. Let p to be ln x all raised to what? All raised power x. And now say let q to be what? Sine x all raised power x. So by the time we differentiate this guy with respect to x and differentiate this guy with respect to x, we just add the answer we got together so that we can have dy dx. So that dy dx becomes dy dx will now be equals to dp dx, which is derivative of p with respect to x, plus dq dx. Do you understand?
Why is x always power sine x?
Oh, sorry, it's supposed to be sine x, not x. Sorry, that was a mistake. Right? This is what you're saying, Abby.
Yes.
So that was a mistake. So if you can differentiate this separately and differentiate this separately, then add the results together, we are going to have what we call dy dx, which is going to be the derivative of p, which is the first expression raised by x, plus the derivative of q raised by x. If it is minus right here, it will be minus here too. So let's go back to our file. So as you can see here, so we said let p to be this and q to be this. You can see my screen, right? Can you see my screen?
Yes, I
So if p is this and q is this, so it means y is equal to p plus q. Let me check whether there is this guy is okay. It's on. So that dy dx will now be what? Dp dx plus dq dx. Now we just need to now differentiate each of them, this and this. So let's start with p. So if p is this, now there's no way you can differentiate this guy directly. There's no way you can differentiate this guy directly like this because you have ln x always per x. So that's giving us a limitation somewhere. So what we are going to do is take ln of both sides. Now we now say ln p is equals to ln of ln x raised by x. So now, this implies that ln p is what? Since you have ln something raised by something, so the power will now go to the back of ln, right?
Yes.
Don't forget, it's not inside this first ln. It's going to go at the back of this particular ln that you took. So it's going to be x ln of ln x, because this one is the argument here in this case. Abi, do you understand?
Yeah.
Okay, now the next thing you are able to is, okay, it's not like a product, that is x times ln of something. So you have an algebraic expression and a logarithmic expression. So we are going to use product rule. Now x is going to be our u in this case, while ln of ln x is going to be our v. Now, how do we differentiate it? Ln p is what? 1 over p dp dx, right?
Yeah.
Okay. So I've cancelled this part. So as you can see, so x, which is our u, times dv dx. How do we differentiate this? What is the argument of ln in this case? What's the argument?
X.
You said?
X.
No, the argument of ln is not x. This is the ln. Ln something. Ln something. So the argument is ln x. So there's ln x inside the ln. So the ln x is the argument. Do you understand?
Yeah.
So how do we differentiate? So we know we are differentiating ln f of x. So we have to differentiate f of x. So since ln x in this case is the argument, so how do we differentiate ln x? Ln x is what? 1 over x, abi? Right?
Yeah.
Then all over the argument itself. What's the argument? Ln x. So we have 1 over x over ln x. Then plus v, which is ln of ln x, times du dx, that is differentiate x, which is what? U in this case, which is this one. If you differentiate x, we have 1. So 1 times v. Now, let's simplify. X times 1 over x is what? 1, right?
Yeah.
So that's why you have the 1 here, all over this denominator, ln x, plus 1 times ln x is ln of ln x. So the next thing is going to happen is that p is going to multiply this, right?
Yeah.
So you have p into bracket all of this. But then we are not done. We have to substitute our p, because we are doing the p dx, so you don't need p to be here. So what's the value of p? P is ln x all raised by x. So that's why we have this guy. So we have been able to differentiate p, which is given as this answer here. Do you understand to this stage? Okay, so next thing is that, okay, let's differentiate the second one, which is what? Q, which is sine x raised power sine x. Okay, which is this part. Now again, we need to take ln on both sides so that our life will be easy. So ln q is equals to ln of this. Since sine x is the power, sine x comes to the back of the ln as usual, right? So then we are able to simplify, then we use product rule again. So ln q, differentiate ln q, that's 1 over q, then put dq dx. Then is equals to product rule. Our u is sine x, our v is ln sine x. So if u is sine x times differentiate ln sine x, that would be differentiate sine x, which is cos x, all over sine x itself. So that's why you have this, plus v, which is what? Ln sine x, du dx, differentiate sine x, what do we have? Cos x. So sine here, we cancel sine here. We are going to have cos x, right? Plus cos x sine x, which is this part. Then now, I can rearrange this cos x times ln sine x. Now if I should come here, I think someone is in the lobby. Let me allow someone in the lobby. Timtayo is just joining us. Timtayo, you are late to the class. Hey, you are late to the class. Timtayo, can you hear me? Hello, Timtayo.
I can hear you, sir.
Oh, okay. Moving on. So, I think I stopped here. Yeah, I stopped here. So, what's going to be the QDX? You multiply by Q, right? So you have Q times cos x plus cos x plus sin x. That is this left hand side. Now you cannot stop here. You have to substitute what our Q is, which is actually sin x is power sin x, which is this times this result. So you have our dq dx. But don't forget our dy dx is actually what from here? It's actually dp dx plus dq dx. That is the first one that we differentiated plus the second one. So we are going to take this value, which is our dp dx, plus this second value. So that's how you have your final answer that is actually here. I hope that is clear to that point. Forgive me. So if you are not clear at the particular point, you can tell me so that I can explain. But Temitayo, we are going to move on. We are going to move on. I said, moving on. Do you have a question?
Me? As I don't call it like this, how we go take that?
So you continue from here now. We catch up. Okay, let me just let me give you a brief what we did here.
Follow with you guys. Are you following the textbook?
Yes. So let me follow from this guy.
All right.
So this guy, we need to differentiate this guy.
Yes.
Y is equals to ln x is pi. But doing this guy directly won't, it's gonna, though I can do it directly, but if I do it directly, I'll be skipping some things in my head that you guys will not understand. But doing the normal method, you cannot just differentiate this guy directly. So, but luckily for us, if you want to differentiate, since differentiation is a linear operator, dy dx here is going to be differentiate this plus differentiate this. Okay, so let's call this guy p. Let's call it a p. So p is this. Let's call this guy a q. Q is this. So it implies that y is going to be p plus q. So dy dx is going to be dp dx plus dq dx. That is the derivative of p plus the derivative of q. As simple as that. So now, since p is this, how do we differentiate this? Now we cannot differentiate this directly. We have to take ln of both sides so that our life will be easy. So by taking ln of both sides, this right hand side, the power here is going to come to the back of the ln. That's law of logarithm. So that we can this guy must simplify it as simple as possible.
Okay.
Here. Then we can use apply product rule on this right hand side to find our differential. And ln p, if I differentiate ln p, is going to be 1 over p dp dx, because that's the derivative of p, 1 over p. Since I'm differentiating the dependent variable, I'll add the dp dx here to not make anything complicated. Then using product rule, u times, if I differentiate ln x, that will be 1 over x over ln x. That is what's the derivative of ln x itself? 1 over x, all over ln x itself. Then from here, we get our final answer to be this. Then we differentiate the second part, q, which is sin x is power sin x. Take ln of both sides. Sin x comes to the back. You have sin x ln sin x. Apply product rule at the right. Ln q is what? Differentiate the q, 1 over q dq dx. Applying product rule here, we have this result. Then sin x comes to sin x, we have cos x plus cos x times ln sin x, which is cos ln sin x. Then take q to the other side, that's cos multiply. You have this, then you substitute your q. Then your final answer is the first derivative that we got plus the second derivative, which gives you the final answer. Now, I want to explain something. I want to explain something. Look at here, I wrote cos x times ln sin x. So I want to show something. Let me go to the web. So I'll use this this board here. So if I have this guy. I have ln q. I think it's ln q I have here to be equals to sin x ln sin x, if I'm correct. Now, if I call this one my u, which is which is sin x, and I call ln sin x my v, by product rule, our derivative is going to be u dv dx, abi?
Yes.
U dv dx plus v times du dx. Now, I have a reason why I'm doing this. You see now, because people get confused and they just so ln q is 1 over q. If I differentiate 1 over q dq dx, then you say it's equals to what? What's my u? Sin x.
Yes.
So if I differentiate ln sin x, I have cos x
1 over sin.
1 over sin x.
Okay. Yes.
First of all, differentiate the argument. Differentiate the argument.
Wait. Yes, which is if you differentiate sin x, you get cos x.
Yes, all over the argument itself. That's how you differentiate ln. It is not 1 over sin x. So if you differentiate ln f of x, if you want to differentiate ln f of x, it's actually f prime of x.
Oh, yes.
F of
Yes.
x. Yeah. It's allowed. So plus v. What's my v? Ln sin x. It's calling me there.
Yeah.
Okay. My v is ln sin x. So I'm following this formula. Ln sin x times du dx. That is differentiate u. If you do sin x, what do you have? Cos x, abi?
Yes.
Here sine cancels sine. I have is equal to cos x. So what will be the answer? Plus what?
Plus cos x ln x now.
Cos x
Ln x.
ln sin x. Not
Ln sin x rather. Sorry.
so, but some people they will say they will now go and write this one, this particular line. They will say it's ln sin x cos x. They will not bring it together. It is not so.
This is wrong.
It's going to be come to the back. So don't be tempted and maybe you have something like ln x times x, for example. Now you're not going to write ln x squared. You have missed it.
Instead of x ln x.
Instead of x ln x. So don't get it twisted at all. Don't get it twisted. This is an algebraic expression. This is a ln. So you can't take this guy and multiply it with his argument. No. It's very wrong. So this is very wrong. This is correct. So that's what I want to explain that part. So let me go to study again. Now, as I said earlier, if you are given any differential problem in mass method, what you are expecting is to take in on both sides. So anything that should come to your mind is take ln. If you go and do product rule or quotient rule, look at, for example, this guy now. I know some people will be tempted to use quotient rule, so I will explain. If you use quotient rule in theory to get your answer, they might not penalize you. They might even penalize you because they don't expect you to even do that in the first place. So let me show you. E is power 4x all over sin square x. E is power 4x. You have y to be e is power 4x over sin square x. Y to be A raised power 4x. Let me see how I can make it. All over, is this sine square as I call it? So maybe you have something like this. If you take quotient, if you do quotient, you say this one is your u, this one is your v. Let's say it's an objective. We now use something like v du minus u dv. You now say over v square or publish formula like that. If you use this, you are correct. So you are correct. But if it's objective, for example, the answer you are going to get using this logic, you are not going to find it inside the option. So it's like you are giving yourself a headache trying to use this in the first place, unless you can now find a way to simplify your maybe your option to get what you got here, or simplify what you got here to fit the option, and that's the stress. That's the stress we would like to avoid. So don't be tempted to use product rule to solve any differentiation problem in math method, or product rule or quotient. Don't just try it. So moving on. So we take ln of both sides here, since it is division that is even separating. If it's multiplication, but if it's multiplication and division that is combining your expression, just take ln directly. But in this second question that we did, you know, it is plus that is combining them. That's why you could not take ln directly. So you have to split it and solve it individually. But here, what is separating them is the division. If the multiplication too, you can take ln directly. So you just take ln on both sides. Then ln y is still ln y. How do we separate this? You know, if you have ln a over b, it's going to be ln a minus ln b. So this is going to be ln exponential 4x minus ln sine square x. Now, the power goes to the back. That's why you have 4x ln e here. Now, minus ln sine x squared. Sine square x is the same thing as sine x all squared. Do you understand that?
Yes.
So now, first of all, we want to try and simplify the right hand side before we start differentiating. So don't start differentiating. So until you are satisfied with what you have at your right hand side. Ln e is 1. Ln natural log of exponential is 1. So that's why you have 4x here. So 4x times 1 is 1. I don't know if you can use the calculator. Maybe the calculator will use one.
Ability.
Yeah? Yep.
I'm lost somewhere.
Okay. Where are you lost?
You said this ln. Is that we should take the ln of both sides, right?
Okay, yes.
So if we take ln of both sides, we are going to have ln y equals to ln open bracket exponential 4x all over sine square x close bracket. Isn't it?
Yes.
Then this line, the other okay. The therefore sign it's another line entirely,
yes,
right?
Or
this
continuation of this one, yes.
Okay.
Right at your right.
Yeah.
So this is the next line, then this is the following line. So ln is 1. So that's why 1 times 4x, we have 4x here, minus, since 2 is the power here, it comes to the back of the ln. So you have 2 ln sine x. Now, we have been able to simplify our right hand side. Now we can start to differentiate. Ln y is going to be 1 over y divided dx, right? If you differentiate 4x, you have 4. Minus 2 is just a constant. You have minus 2 times differentiate ln sine x. So first of all, differentiate sine x, which is cos x, all over sine x itself, because sine x is the argument. So this implies that, so continue from this left hand, 1 over y divided dx is equals to this 4 minus 2 times cos x over sine x is the same as cot x, right? If it is sine over cos, you say it's tan. But if it is the other way around, it is cot. Are we clear to this side?
Yes.
Okay. So, but we need the y dx. So you get y to cross multiply. Then we have the y dx is y times 4 minus 2 cos x. Now, if it's objective, your answer will be left in this format, as I said earlier. Your answer is going to be y into 4 minus 2 cos x. But you can say that 2 is common in this bracket. I can bring 2 out. It depends on you. If you look at the option, maybe, okay, they actually brought 2 out of the bracket. You can bring 2 out of the bracket and compare your answer. So most likely your answer is going to be left in this format. They won't substitute for y. But if you are doing theory, you have to substitute what your y is. So what is our y? Exponential 4x over sine square x. Give it here. This guy, Stephanie. Is that clear?
Yes.
Okay, good. I think we are going to move to the integration part. Now, moving on to integration. Moving on to this part, my time to start. Look at this. We have integral of dx over x squared plus 6x plus 13. Now, how do I integrate this problem? Now, integration is harder than differentiation. Some people might argue it, but it's not even arguable. Why will you argue that rubbish? I mean, there's someone here that feels like differentiation is harder.
No, no.
So this is how it is. This is how differentiation and integration is. Differentiation is that I want to go and destroy something. Integration is I want to build. To destroy is very easy. To build, it is not hard. And why is it like that? To destroy, let's say I want to destroy my phone. There are different ways. There is 1,000 ways I can destroy my phone. I can put it inside the water. I can put it inside the fire.
Choose some.
I can break it on the floor. You know, to destroy something is you have different. So that's differentiation for you. To differentiate, you can use different pattern. You can take clean. You can use product rule. You can use chain rule. Any which or water. But integration, it follows. There's this it follows a particular method. It's very restricted. You cannot integrate anyhow. Come and say I want to do rubbish. So if you want to build a phone now, there are some specific method for you to build the phone. But if you want to destroy the phone, my friend, you have many ways. You can even use saw or hammer. So that's just differentiation and integration for you. Now, how do we now integrate this problem? I'll give you an hint. I'll give you a guide when it comes to integration of rational function like this. Now, so I'll give you a genuine case study. So if you want to integrate a rational function, now these are the cases you're going to consider. These are the cases. You have integral of let's say f of x. Now I might not write all I'm saying. I won't write all I'm saying. You have to do the right thing. You have to do the right thing because I will say a lot under this part. If anyone is not clear, tell me. Now, if you have the integral of this kind of function, now, first thing you consider, this guy. This is what the numerator. So let me do. I don't like the way this thing is. The numerator. Then you have the denominator. But the first thing you're going to consider is this numerator. What are we considering? You are comparing the numerator and the denominator. Check. First rule, you check. Is the degree of your numerator, so it's actual function, f of x and g of x, they are polynomials here. They are polynomials. But anyway, they can be exponential, but let's just put it as polynomials. Now, the degree of f of x, if the degree of f of x is less than g of x, so if the degree of f of x, so don't let me choose less first. If the degree of f of x is greater or equals to g of x, sorry, is equals to the degree of g of x, is greater or equals to the degree of g of x, then the first thing you're going to consider about this integration is to take long division. So if the degree of f of x, which is or equals to the degree of g of x, we say you do long division. What am I talking? So what do I mean by degree? So we have something like x squared minus 3. This is a polynomial with degree what?
Degree of 2.
Degree 2. That's the highest power. If I have a constant 2, the degree is what?
0.
0. Good. If I have x minus s cubed plus 3, the degree is what?
X minus
s cubed.
The
degree is
plus
what?
3. 3.
The degree is 3 because it has the highest power, which is 3. So that's the degree for you. So whenever the degree of the function at the numerator is greater than the degree of that of the denominator, you proceed to first do long division.
Long division.
That's step 1. Now, step 2. Let's say step 1 is not satisfied. So if step 1 is not satisfied, what does it mean? It means that degree of what? F of x is what? Is actually what? Less. In this case, Abi? Abi? Is that not it? If you say that step 1 is not satisfied, it means it has to be the opposite, that is less than degree of g of x, right?
Yeah.
So if this is the case, proceed to step 2. So I'll talk about step 2 now. But if the case is this case, do step 1, which is what? Long division, then proceed to step 2. But if you check the degree, it is this case, you don't need to do step 1, come to step 2. So what is the step 2? Step 2, you are not going to check. So you are not going to go to your denominator in this case. Check the denominator, which is your g of x. Can you factorize g of x? Can you factorize g of x? So is g of x factorizable? Can you factorize g of x? You ask that question, which is the denominator. If your answer is yes, step 3 is going to be what? Step 3 is going to be factorize g of x, so that g of x will be something times something. So if it's a power of 2, you have to have something like x minus a or x plus a times x plus b. You're going to have something like this. If it's a power of 3, maybe it can be factorizable to maybe
into 3.
It depends. But if you can shall write it as something times something in this case, then you say it's factorizable. So check, can you factorize it? If yes, factorize. Now, after you have factorized, you now resolve to partial fraction. You now resolve to partial fraction. So that will be the next step. That's if you check that if it is factorizable. So you are going to have 2 steps like that. Now, if you check your step 2 and you check that it is not factorizable. So first of all, my step 3, if it is factorizable, is what? Resolve to partial fraction. Write it down. Then after you have resolved to partial fraction, no, you first of all factorize if it is factorizable, then resolve to partial fraction. Then step 4 is going to be what? Solve. You now solve, that is integrate in that case. You'll be able to integrate. But if you check your step 2 and see that it is not factorizable, then what you are going to do in your step 3 is not going to be result to partial fraction, and it's not going to be factorize because you cannot factorize it. Your step 3 in this case, if your g of x you cannot factorize it, is do what we call complete the square method. You do what we call completing the square method. Completing the square method. You can write it down. Completing the square method. That will be your step 3 if it's not factorizing. Now, after you have done completing the square method, then you now solve. But there are still some things you might need to do after that, but I don't know whether I can break it down. So after you have done completing the square method, there are still some rules that will apply. But that will be explained as I move further into the different kind of formats you have. I think let's go. I think I've already explained this. So have we finished writing? Can we move on? It's essential you write this down so that you can think over it again so I can master those steps. Can we move on?
Sure.
Okay, so I'll just stop this part. Now, let's go back to our question. Now, this guy, the degree of the numerator and the denominator, so the degree of the numerator, is it greater or less?
The numerator is less than the denominator.
Is lesser. It means I cannot do long division. So
Yes.
this does the intuition. It's like, okay, if I have 3/4, there's no way I can write this one as what we call maybe a mixed fraction, because this one is lesser. But let's say you have like something like 6/4 now. Then you can do something like, you now say 6/4 is now you are going to do what we call division.
Number
In that case, you now say 2 whole number 1/4.
No. It's 1 number 2/4, sir.
What am I saying? 1 number 1 and 2/4, abi?
Yes, sir.
So this intuitively it means 1 plus 2/4.
2/4.
You can say 1 plus, you say reduce to simplest term, 1 plus 1/2. So that's what
Yes.
with your this guy, with your f of x over g of x. So by the time you do f of x over g of x, now what you are going to have if you are doing long division is what we call, you are going to have something like p of x plus q of x all over g of x. You can see the denominator here is still g of x. What we are trying to say in essence, your p of x here is your 1, your q of x here is your 2, your g of x remains the same, which is your divisor. So this guy is called, I will call this p, which is polynomial. I'll call this one quotient. Sorry. What am I writing? I'll call this one remainder. Then no, that's not it. Sorry. This is our quotient. I'm supposed to call it q. This is my remainder, while this is my divisor. In essence, this is what I'm saying. If I have a polynomial all over a divisor, the answer is going to give you a quotient plus a remainder all over what? A divisor. So if I use this intuition, my 6 here is my polynomial, my d here is the divisor. So my quotient is what I get when I divide 6 on 4. Okay, 6 divided by 4. Okay, ìgbà mélòó ni 4 máa lọ nínú 6? 1.
That's 1.
That's my quotient. Kí ló máa kù? My remainder 2.
2.
All over what? The divisor 4. Do you get the logic at all?
Yes.
Who is this person? Hold on, let me just.
Telling me how far. I don't understand something, so you explain to me. Eh?
I said okay.
Yes. Can you media? I'll call you when I'm done. I'll be leaving the office by 7. Can I call you later? I'll call you later. I'm in the class. So, sorry about the break in transmission. So,
Fine for that next time, sir.
so 1 here is, this is like 1 over denominator times dx in this case.
Ability, this thing, sorry to interrupt you. This thing is not very clear. Yeah. I don't know. Maybe you follow me. Are you saying the same thing?
Oh, yes, no, that's
But
Exactly. Maybe
maybe I should write it. Okay, let me do something. Let me use a word. Let me use word. The word. So I didn't want to use word. I think I just feel like I don't know. Let me use word. So I just feel like it will be easier when you do some kind of insert, blah blah blah. Okay. So I want to insert an equation. Kalili. Abba. Don't mind this guy. So I want to insert. So we have 1. Can you see this guy?
I'm not
X.
seeing it yet. Against this thing is breaking here.
Okay, your own thought it's kind of okay. Maybe it's a network thing. You see it.
It
So
has to be for you.
sorry. Um. So let's say you have x squared, s squared, s squared, s squared, s squared. X squared plus 6x, I mean, x squared plus 6x plus 13. So once you differentiate this guy, let me enlarge, let me enlarge the size of this stuff so you can see. How about like this?
okay.
So this is what we want to integrate. The dx is just like you're multiplying by dx, you are not, it's not really necessary, so you just put it, I can just put the dx here. So this is what we want to integrate. So now, in this scenario, the degree of my numerator is 0, the degree of my denominator is 2. So it means the degree of the numerator is less than that of the denominator. So I cannot do long division. Proceed to step 2. What's step 2? Check. Can I factorize? No.
No.
Abi, I cannot factorize. Now in this case that I cannot factorize, I will do what we call
Completing the square method.
completing the square method. So how does completing the square method work? So let me copy this. Okay? So you are going to have something like this. Say x squared plus 6x plus 13. So what do you want to complete? You want to complete the square of the guy in the denominator. You want to complete the square of this guy. I must set this thing to this thing. So you want to complete the square of this guy. So what you are concerned is the coefficient of the what's coefficient of s squared? First of all, check what's coefficient of s squared. It is what? 1. So if the coefficient of s squared is 1, you are safe to continue. Now the next thing you check, what's coefficient of x? 6. sorry, coefficient of
Six.
x 6.
6.
All of this, write it down so that. So check coefficient of x. First of all, check coefficient of x squared. Is it 1? Yes. Move on. Coefficient of x is 6. Now 6. So what are you going to do now? Since coefficient of x is 6. Now
Divide it by 2.
before you move on to do this guy, check your numerator. Is it a constant? Yes, it's a constant. If it's a constant, fine. But you're still going to do complete square. It doesn't matter. So let's first do the complete square. 6. You have checked your coefficient of x to be 6. What you're going to do is that, okay, divide that coefficient of x, which is 6, by 2. Coefficient of x by 2. And this is going to give us what? 3.
3.
You are going to square. You are going to square the result. Now, first of all, what did I say? I said check the coefficient of x squared. Is it 1? Okay, fine. But if it in the case whereby coefficient of x squared is not 1, what you are going to do is that you are going to factorize. Let's say, okay, coefficient of x squared is 2. It means I'm going to factorize out 2 from this denominator, so that I will now have x squared all over 3x over 13 plus 13 over 2. Do you understand? Do you understand?
Yes.
Kwame, are you following?
Oh,
No. What's the problem?
what you just said.
So I said, okay, let me go to my screen here so that you can get what I'm saying. So I said, for instance, let's say my coefficient of x squared is not 1. So let's say I have something like this: 2x squared plus 6x plus 13. Since my coefficient of x squared here is not 1, I cannot just do my completing square, and I'm going to have issue because of this 2 here. So what we are going to do? I'm going to make the coefficient of x here to be 1. I have to factorize 2. So if I factorize 2, I'll take 2 out. So it means 2 squared over 2 is what? S squared. Abi? 6s over 2 is what? 3x. Plus 13 over 2 is what? 13 over 2. Just put 13 over 2 there. So you are going to do this. Do you understand that? Do you understand now?
Yes.
So if you want to not do your completely square method, you are going to do your completely square method on this guy that is inside the brackets. so let me to my word. So here, since my coefficient of x squared is 1, I move on. Okay, what's the coefficient of x? 6. Divide the coefficient of x by 2. That's why it's 3, as you can see here. Then you are going to square this result you have here. This is 9. Now, the next thing I'm going to do is that, okay, moving on. How do I complete the square of this guy? So I'll come to this next line. All right, okay, x squared plus 6x. Immediately after 6x, I'll put plus 9 minus 9 based on this value here. Are you following?
Yes.
Now, plus 9 minus 9 is 0.
Yes, yes.
So it does not change anything from this thing, right? Now, from this first place, which is x squared, to this positive 9, just put a bracket there. Now, what now happens?
That's going to become x squared.
Go to the next line. So this guy that is inside the bracket becomes, is going to become, insert, it's going to become a perfect square.
Yes.
So it's going to become
X
plus 3 square.
plus this guy.
3
This guy is divided by 2. So x plus 3
square.
all raised power 2.
Mm.
Obviously, if you open this bracket, you're going to get the same thing as here, right?
Obviously.
So what is minus 9 plus 13? Is 4.
That's 4.
So plus 4. Now, if you have this scenario now, so you have been able to write this guy, which is the denominator, as this guy. Now we have achieved this point. Now, this particular one that is here, so whether it is 4, sometimes it doesn't usually be a perfect square. So 4 is a perfect square. So whether it is 4 or anything, so let's say it is not 4, let's say it's 3. So let's say it is 3. So how do I write 3 to be something square? So I will now put square root of 3 all squared, which is the same thing as 3. Are you following me?
Mm.
Because I want to write 4 as something square. So for me to do that, I'll put it's going to be 2 squared. 4 is the same thing as 4 is the same thing as 2 squared. So let me start. So instead of me to put 4, I'll put 2 squared.
Square.
Remove this. I'll remove this 4, which is the same thing as 4, right?
Yes.
Now, here, I'll now say this guy.
The way 42. Okay, you've changed it.
So I will now say this guy is now equals to this. Are you stupid? You mind this guy sometimes. So let me just write it again. So let me insert it here. So this guy is going to be x plus 3 squared plus 2 squared. Do you understand this part, please?
Okay, continue.
Now, there is this rule. When you have something of this structure, so I will tell you what the rule is. Now, if you have something of this structure where you have B, something of this structure, automatically your answer to this problem is by default is this by default. It's going to give you, let me use rational function. Then let me put another. By default, it's going to be 1 here is this one that is on top. If it is 2 that is here, if it is 5 that is here, this guy is going to be 5. So 1 over what? B. Remember that B is in square format. 1 over B. Let me fix. 1 over B times is per minus 1. Arctan x over B. So anything in this format given as this. So the integral of any expression in this format is given as this. Now, if you should compare this guy with this guy, you see that they are almost the same thing. The difference is that this one is x, this one is x plus 3. So your answer for this question in this case now, instead of me to put x here, I'll put x plus 3.
Put x plus 3.
Exactly.
All over 2.
My b will now be 2 in this case.
Then plus c.
Now add your constant of integration, which is plus c. So my answer to this problem here will now be 1 over b. My b in this case is 2 plus arctan x plus 3, because my x in this case is x plus 3 all over 2. Then you now put your integration constant.
Yes, sir.
Plus do you understand?
Yeah.
So you have to understand all these concepts. I think you should have them in your textbook. Something that is in new format. Then you have another one. If
Ability. And sorry, I'm bringing you back. I don't know if it is possible for you to give us this. How do I put it? The Are you with me?
the format of these integrals.
No, not even the format. I'm talking about the lecture. How do I put it? Lecture. Should I call it lecture note?
I'm going to make the recordings available. So this is what's going to happen. Tenta, do you have your what do we call it? Are you using your laptop or your phone?
I'm using my phone.
So do you have your compulsory email? Do you have it with you? Do you
Compulsory
have
email?
Yeah, you like give you guys.
Yes.
And you know the login
That
credential.
Microsoft.
Yes.
More. Yeah. I should still know it.
Somebody still knows that. So I'm going to show you how you can navigate around and see this recording of this class. Is that clear?
Okay.
So let's move on to the next question. So that's how we got this final answer that is here. As you can see here, you cannot see the screen. Can you see the second question? Can you see the second question?
Yeah.
Tenta ṣe lè rí àbí kí n lọ sí kí lọ kọ́ ní word. Let me use word. I think this will be our last question for the day. Then we'll meet tomorrow again. So let me write it in word. So I'll just copy this. So question 2 is this guy. Now what's the question again? Let me see. I will have 2x plus 3. Here I have 2x plus 3. No, one is not there. All over 4x squared minus 4x plus 5. 4x squared. 4x squared minus 4x plus 5. So this is the question we want to solve. Now, first of all, the numerator, the degree is less than that of the denominator? Yes.
Yes.
Since it is less, you cannot do long division. So I want to make so if it is less, you are good. You are good. Now, if it is greater or equal to, you have to do long division. But if I should do, I want to tweak this thing and make the degree greater or equal to, so I can use long division. But if I should do that, let me see. Okay, let me tweak it so that the degree will be lesser or equal to, so that you can see how we can apply that. Do you understand?
Yeah.
Let me remove this and make it so I'll put 2s squared here. Now, in this case, the degree of the numerator is now greater or equal to that of the denominator. So in this case, I have to do long division. So how do I do long division? So in this case, this is my p, and this is my polynomial, this is my divisor. This guy is my divisor. So let me go to equation. Let me do division, Jare. Let me copy this guy first. Let me see if I can copy this one. Okay. So this idiot. First of all, let me insert equation. Insert equation. Then I'll now put this one. So let me first of all write this. 4. I'll now say 4x squared. Sorry, let me put this. 4x squared. This is what I want to divide 4x squared minus 4x plus 5. What I want to use to divide it. So I'll put this guy. 2x squared x let me go and use the board. Let me go and use the board. I think it's better that way.
Because this is looking too complicated.
Let me use the board. Where are we? I don't know nation. So answer me. Okay. So I want to do divide. What am I dividing again? What's inside the box? 2x squared plus 3. So 2x squared. This is 2 plus 2 divided by what? Divided by 4x squared minus 4x plus 5. 4x squared minus 4x plus 5. Now, if you want to divide
it's not meant to be division. You are using square root sign.
It's division. Don't mind the square root sign. It's division I'm doing, not square root. So I'm doing this value of this. So now this way you write it. Most of that you write it like this. They use this. So you arrange it in the order of degree. S square comes first. So the highest degree comes first, and next, and so this way you do the division. This is you are using the highest degree to divide, which is 4x squared. But you start a division from this guy too. Then it goes. So what is 2x squared divided by 4x? So what's 2x squared divided by 4x squared? 2x squared over 4x squared. X squared counts for x squared, abi? 2 here 1, 2 here 2. That's 1 over 2, abi? Right? Okay. So what is 1 over 2 times? You now use this 1 over 2 to multiply everything here. So 1 over 2 times 4x squared is 2x squared. Now, 1 over 2 times 1 over 2 times minus 4x is what? Minus what? Minus 2x. Is that right?
Yeah.
Let me erase this part. Now, let me change this 5 to 6. I don't like having this. I don't want to have division. What we call it, fraction for that guy. So that's why I'm changing down. Though you have fraction, so I'm just trying to avoid this because of that time. So 1 over 2 times 6 is what? 3, right?
Yeah.
Then you now, so you have gotten this, you now subtract. Now this subtraction is affecting everything here. It's like you are doing minus into bracket all of this. So don't get it twisted. So 2x squared minus 2x squared, 0. Now, you know, there's no coefficient of x in this upper part. So first of all, minus 2x is what? 2x. Abi?
Yeah.
Now, 3 minus 3, 0. Abi? I'll call you back. I'll call you up. Are we still following?
Yes.
Okay. Now, since there's nothing left, this is what is left. Can we continue with our division? No, because the remainder you have here, the degree is smaller than that of this degree here. So you cannot continue division. So in this case, this guy is going to be our remainder. This guy is our quotient. Do you understand? So our P over Q, which is the polynomial, this is our polynomial. This is our divisor. So our P over Q will now be, what am I writing? P over D, polynomial divided by divisor, is now Q, which is the quotient, plus what? P, R over D, that's 2x over what? 4x squared. Sorry. 2x over 4x squared minus 4x plus 6. I change to 6. Do you understand? Do you understand?
Yes. Somehow.
No. Don't say somehow. What facts don't you understand in this case scenario? You know, I gave you guys to write something down that P over D is R plus, sorry, not R, Q plus
So,
R over D. Someone is in the lobby, let me allow the person. I'm tired. Your network got you out, your network slide. So, okay, that's it. So, this guy, all about this guy, our polynomial divided by divisor is now our quotient plus our remainder over divisor. You know, the way we did something like this, I will say, okay, 5 over 2 is, how many times will 5 go in 2 places? What will remain? What's the remainder? 1 over what? 2. So, quotient plus remainder over divisor. Do you understand now?
yes.
So, going back to this place. So I'll change this one to 6. I'll change it to 6. So now instead of me to have this as my original question, this is what I'm going to have. I'm going to have this guy. I'll be able to divide that guy to become this. If I simplify this, I'll still have that same guy. So this one is now equals to, our original question will now be equals to, so let me clean this one. This guy is now equals to half is now equals to 1 over 2 plus, I think, 2x, Abi.
Yes.
x all over this. Now what you now have. So instead of me to integrate this one, this is what I'll be integrating now. Now, don't forget that this is what we have, like everything into brackets. This is what you're integrating. Now, this guy, integration is also a linear operator. So what do I mean? What do I mean? I finally move. If I'm integrating, if I'm doing something like this, if I'm doing integral of p of x, p is a function of x, plus q of x dx. The same thing as integral p dx plus integral q dx. It means integrate p plus integrate q. So the same thing is going to happen here. So this is going to be equal to, this one is going to be equal to, so I can remove this bracket, say integral half dx plus, I just need this integration sign, plus, let me put this sign, plus integral, let me just, I don't know that I can remove this guy, just this guy. So let me copy this. So plus integral. What did I do? Okay, yes. Plus integral this dx. So this is the same thing as integrate half with respect to x plus integrate this with respect to it. Are we clear to this stage?
Yes.
Now, if you integrate half, what's the answer if you integrate half?
That's x. 1 over 2x.
So that's half x. If you integrate the constant a, so let's say you are integrating a with respect to x, where a is a constant. So the answer is ax. So this one is going to be half x. It means this part of integration is done. Now it's now left for us to integrate this one now. This is now our headache. So first of all, we are done with this part. So let me just input it here. So this is going to be half x, which is the integral of half. Now, how do we now integrate these jargons here? That's our headache. How do we integrate this jargon? First of all, 2 is common. 2 is common.
Yes.
So I can have this guy to be, I can remove these 2 here. Then I'll have 2 here.
2 and 3.
I have 3 here. Are we on the same page? Are you on this call? I didn't get a response. What to say?
I said yes.
Okay. So how do you now solve this guy? Now you now come back to that logic we told you. If you want to integrate the rational function like this, first of all, now is the degree of the numerator lesser than that of the denominator? Yes.
Yes.
Now check the denominator. Can you factorize? No. You cannot factorize. So in this case, we want to do completing the square. layout. Completing the square. So I will copy this guy. We want to do so what are we completing? Denominator. I want to complete the square of the denominator. But then, before you do that,
Yeah.
your numerator is not a constant. Your numerator is not a constant, but that doesn't stop you from doing complete the square. You are still going to do complete the square. So let's complete the square first. But take note that your numerator is not a constant. Have that in the back of your mind. So if you want to complete the square, what do we have? We have 2x squared plus minus 2x plus 3. Now, when we talked about completing the square, he said we are going to consider coefficients of what? Of x. Is it 1? No. The coefficient of x is not 1. Right?
Which of the x are you talking about? Is it the are we talking about
the coefficient of x square rather? Is the coefficient of x square 1? No, it is not 1. Since the coefficient of x square is not 1, you have to factorize it so that it becomes 1. So it means you have to factorize 2. Abi?
Yes.
So that will be 2 into bracket x square minus x, right? Plus 3 over 2. So this one is going to be 3 over 2 in this case. So
Plus 3 over 2.
Plus 3 over 2. So I have to put 3 over 2 there. Plus 3 over 2. Now, what you want to complete the square method of this guy that is inside the bracket. Now, since the coefficient of x square is now 1, what's the coefficient of x? What's the coefficient of x now? Hello. What's the coefficient of x? Minus 1. Is that not it?
Yeah.
So I'll put minus 1 here. Now divide the coefficient of x by 2. Divide minus 1 by 2. What do you have? You have minus 1 over 2. So I'll put
minus 1 over 2.
1. Now square the result. If you square minus 1 over 2, what do you have? I have 1 over 4. Is that not it? If I square minus 1 over 2, is not 1 over 4 I would have.
Yes, that's 1 over 4.
So what is now going to happen next? We are now going to come here. So immediately after this x here, we now add 1 over 4 and subtract 1 over 4. So I'll say plus, as I've done in the last, plus 1 over 4 minus 1 over 4. Then plus this one, plus this 3 over 2 that we have from here. So now, you are going to consider from this place positive 1 over 4. You know, we are going to have a perfect square from here. Go to the next line. So it means this guy here will become I don't know, 2 into brackets. So x squared minus x plus 1 over 4 becomes, so let me insert, that will become x
minus 1 over
2 all squared. So x, then take this coefficient here. Let me insert equation. Equation. Sorry, not this. Okay. So x minus 1 over 2. So let me just copy this guy. X minus. So this one 1/2. Maybe X minus 1/2. So this one will be 1/2 all squared. Okay, so now minus 1/4 plus 3/2. What will be our answer? Let's actually simplification. Let's go to our blackboard. Minus 1/2. Okay, 1/4. Sorry, plus 3/2. What's our LCM? 4. 4 divided by 4, 1. 1 times 1 is 1, minus 1. Plus 4 divided by 2, 2. 2 times 3, 6. Minus 6 plus minus 1 plus 6. That's 5/4. So we come back to our drawing board. So here, this is going to give us plus 5/4. So it means you have been able to do completing the square for this guy. Now, before we now proceed, I told you that. So let me copy this line.
But
Let me copy this line down here so that you can pick it up from there. I told you that the coefficient of this x, the numerator is not a constant. You have to have that in mind. So how can I get rid of this guy? How can I get rid of this guy? So what you try to do is that you try to write the derivative of this denominator as a linear combination of this guy. So what am I trying to say in essence? If you differentiate 2x squared minus 4 minus 2x plus 3, what do you think you're going to have?
I'm going to have 4x minus 2.
You're going to have 4x
minus 2.
minus 2. So you're going to have this. So it means what I want to achieve is that I want to write this guy as a linear combination of this guy, so that instead of me to have x, there's a way I want to write x so that I can write it in combination of this. So what am I trying to say in essence? So what I want to do is that I want to write, so let me copy again. So I want to write x to be equal to a particular, so let me use a symbol in this case, a particular alpha into bracket 4x plus 2. Is it plus 2 or minus 2? Minus 2 plus a particular beta. So alpha and beta are constant. So I want to write x so that x will now be equal to a constant alpha times 4x minus 2 plus a particular constant beta. Me, the way I used to write it, I used to manipulate. Me, I can manipulate. I might not pass through this process. So let me teach you the manipulation, maybe. But sometimes it's not easy to do the manipulation. You won't find it easy to do it. But if you are not having a fraction up here, it's actually easy to do the manipulation most of the time. And so this is what I'm saying. So I want to write 4x. I want to write x. So I want to write x to look like something like this. Minus 2 plus beta. So I want to write this as a linear combination of the derivative of the denominator. So what I'll just do, I'll say x. I want to do something like 4x, Abi. And I'll say x is equal to 1/4 times 4x. Abi, is that not true? Right?
Yes.
And I'll say okay. I need minus 2 to come inside. And I'll put 4x minus 2, but I will add plus 2 so that I won't be doing any. I won't be changing the whole expression. Do you understand?
I'm lost too. I'm lost.
This is half 4x. This is just as x, Abi. Now inside this.
Okay. I grab.
I'm putting minus 2 plus 2. You know, it still cancel, right?
Yes,
So
yes.
I will now say this is equals to 1 over 4 into 4x minus 2 plus 1 over 4 into 2. So yeah, so this is now actually equals to 1 over 4. We'll simplify, we'll fill it by into 4x. I hope you understand Yoruba now. Minus 2 plus what? Half. Because 1 over 4 times 2 is still half, abi? So in this case, my alpha now is what? 1 over 4. My beta is what? Half. Show you.
Crap.
But sometimes you might not be able to manipulate it this way. So if I'm doing so your objective, this is the way I used to do it. I don't write all this scenario that is here and try to, but I'll teach you how to do the scenario. So okay, let me go to my so do you get the logic? So I will call x by to look like something like this. Now, so if you expand this bracket, if you expand this, how about expand the vacancy? What do we have? So let me write it in the next line. So I have this one to be 4. I'll remove this bracket. I have 4 alpha x. Shebi? Alpha times 4x, 4 alpha x. Alpha times minus 2, that's minus 2 alpha. Minus 2 alpha. Then plus beta. Abi now?
Yes.
So the next thing you're going to do, you are going to compare coefficients. So you are going to do comparing coefficients. So if you are doing comparing coefficients now, comparing the coefficient of x. The coefficient of x at the right hand side, at the left hand side is what? 1.
How? I don't understand.
The coefficient of x here is what? 1.
1.
What's the coefficient of x here?
4a.
Is it a or alpha?
And 4 alpha.
So you are saying that 1 is equals to 4 alpha. You understand? Do you understand?
Okay.
Are you with us? So here, now you want to compare the constant coefficient. Constant. At your left hand side, you don't have any constant, right?
Yes.
So that's 0. What is the constant you have at the right hand side? Minus 2 alpha.
Minus 2 alpha.
Plus beta. So you have 2 equations. So this one is equation 1, this one is equation 2. From equation 1, what's your alpha?
Alpha is equals to 1 over 4.
By just doing making alpha subject of formula now. So your alpha is now equals to 1 over 4. About answer. 1 over 4. As you can see in the manipulation we did, like by alpha, alpha 1 over 4.
Yes.
So we need beta and beta. What's it called? So for us to get beta from here now, I can substitute value alpha and beta here. So
yes.
Substituting alpha here, what do you have? Minus 2 times
minus
1 over 2. That's minus 1 over 2. So to get beta, send minus 1 over 2 to the other side. This is what?
Correct lines.
That's beta is going to be what? 1 over 2.
1 over 2. Wow, smart work.
So it's about doing smart work, as you have said it. Sometimes you don't need to do all this analysis scenario. You just have to do manipulation. So beta is 1 over 2. And from the manipulation we did here, we got alpha to 1 over 4 and beta to what? 1 over 2. So the essence is now that instead for me to write x here, I will now put this illustration I have here. So instead of me to have x, sorry, let me create that. So instead of me to now have x, this is what I will have because it's actually the same thing as x. So I will now have. So let me copy this again. Let me put it here. So instead of me to add x, this is what I will have at the numerator. Then substituting what alpha and beta is. Baba. Substituting what alpha is. Where alpha is 1/4 and beta is 1/2. Do you grab at all?
Yes, yes.
Now the next thing is that we now separate. Okay, this is A. This is like A. Now separate. We now have A all over this plus B all over this. You know we have let me get this. If I have A plus B all over C. The same thing as A over C plus B over C. Yes,
Yes.
exactly. So that's what we want to do.
Hello. Hello. Hello.
Wait, I don't think he's here again or what. I don't know.
I guess it's his network.
So it's just both of us.
We teach ourselves now. I mean,
The last thing he did, I didn't even understand it at all. Because I was quiet.
what do you say?
I said the last thing he did about the alpha and beta stuff. That you
Yeah,
know,
I'll explain. I'll explain to you. I'll send you.
okay.
The network is bad. I was actually thinking it was my network.
So confused.
It's almost time actually. So let's just wait. Or should I put him on call?
Yeah, I said that.
Let me quickly call him and ask how far. Baba have Japa.
Mm.
I guess it's network because we are both hearing ourselves here. So
Exactly.
if it's not here,
Hello, can you guys hear me?
Yes.
Don't mind my net. My network just went off suddenly. So this guy, we separate this guy now. So I have to remove this guy.
Ability, please come again from that other side I stopped.
Can you see my screen, Sha? Can you see my screen?
I'm not seeing your screen yet.
Let me.
I'm only seeing Pelumi.
Okay, what about now?
But that's it.
Okay, what are you saying, Temitayo?
Maybe when you screen so first, because I'm not seeing your screen yet. Pelumi, what were you talking about the last time?
I said that where alpha and beta so there is no understand particle.
Okay,
But
don't worry. I will explain it. I will send you his name. Explain.
but do you understand to this stage?
She does not understand. Maybe you should come again.
Do you understand this part? Well, do you understand this part? So what we're trying to do is that now, since we have done the long division and the whole thing, and we got to this stage, you check, okay, is this guy the degree is lesser? So okay, now check the denominator. Can you factorize? No. So since you cannot factorize, say we are going to do completely the square. But we've done our completely the square here. We got to this place, right?
Yes, yeah.
Now our problem now is this guy. This guy is not, I don't mean it's a constant. We just put this guy here first, then we continue. But this guy is not a constant. So how do we solve this challenge? Now to solve this challenge is that we are going to, okay, what's the derivative of this guy? The derivative of this denominator is 4x minus 2. So how we can overcome the challenge is to write this numerator as a linear combination of this derivative of the denominator.
Okay. I guess.
So that we'll be able to write x to be equals to maybe a constant alpha times the derivative plus a constant beta, and we did a manipulation as gathered to find the alpha and beta thing without going through this process. But within this process is the mathematical procedure you should follow. So we expanded this bracket. So you are trying to find x to write the denominator x to be equals to alpha times the derivative of the denominator plus a particular beta. So expanding this bracket, we have this. Now by comparing coefficients, so comparing the coefficient of the left hand side with the right hand side. Here, coefficient of x here is 1, while coefficient of x at the right hand side is 4 alpha. So you are saying 1 is equal to what? 4 alpha. Now comparing the constant coefficient. What's that?
No, I was just having issues with this thing before now. I'm always wondering how to go about it.
So comparing the constant coefficient, the constant at the left hand side is 0 because we have only constant. But the constant at the left hand side is minus 2 alpha plus beta. So 0 is what? This. Since you are saying that 1 is equal to this, it means alpha is what? 1 by 4, but like dividing both sides by 4 now. So you have this. Now substituting alpha into the second equation, we are able to get beta, which is what? 1 over 2. Do you understand now? Now, so we are saying that x is now equals to what? 1 over 4 times this plus 1 over 2. So instead of me having x here, I will replace x here with this. And that's what we just did here. Do you understand? Now, we now said we have to separate this guy. We have to separate this guy. So what do I mean? That's why I came to the drawing board here. To say, okay, a plus b over c is the same as a over c plus b over c. So what we're going to do is, now half of 4x minus 2 is our a in this case. Then this other one is our b. So we're going to separate this. We are going to have 1 over 4 times this all over the denominator. So I'll remove this part. I'll remove this half part here. Okay. I'll now say dx plus, so let me, I cannot copy. So let me just insert equation plus, then plus this. Let me see whether I can copy this. Plus this. Plus, then I'll remove this part. Plus this. Plus half times this. Do you understand to this place?
Yes.
Now, what will now be the integration of this place? So this one here, this first one.
The first one.
Yes,
The
this
first
one.
one is
This one.
going to be ln of the. It's going to be the ln of the denominator.
Yes, because if I should differentiate the denominator, I will get this particular numerator. So your answer is going to be 1/4 ln.
The ln of the denominator.
Because if you have something like this.
Oh, 1/4 has to come out though.
Yes, exactly. If you have integral a is a constant here, f prime of x over f of x. Since if I differentiate the denominator, I'll get the numerator. My answer is going to be a.
Yes.
Your a is ln f of x. Balumi, are you following?
Yes, I am.
So since 1/4 is a constant, 1/4 is going to come out. And if I should differentiate this guy, I will get this guy. So the integral of this question will now be 1/4 ln the denominator. So okay, moving on. Let me copy this and put it here. So our answer to this particular one, my friend, okay, will now be God, ln this is just vexing me,
frustrating because they are typing.
So it's going to be ln 2x squared minus 2x.
2x plus 1/4.
That problem is now this guy, but it's not a problem. So why is it not a problem?
You forgot to put the 1/4.
Okay, I didn't put this one. Okay, so let me copy this. This at the back. Okay, good. So the other problem to solve is this guy, but it's not a problem. So why is it not a problem? Because now we now have constant at the numerator.
Yes.
We are able to do the completing square of this one. So what I just need to put here is the completing the square. So I will do that. So I will move it. Then I'll put the completing the square, which we have done here. Yes. I'll come and just copy this and copy this guy now and put it inside this place.
Why can't you copy?
Give me my phone. Okay. Let me try to do this. Sí wàhálà. Ẹni tó bá náà gbọ́n jù yẹn lọ, I'm sure ẹ̀kọ́ agbọ́n jù lọ.
You just put the.
So this is it, Abi. Now this two, we've got it out. So what we are not going to have now is this. Coming to the next slide. I'm going to enjoy the lesson. So if this 2 is going to come out, this 1/2 is going to come out too. This 2, 1/2.
Yes, it's not going to cancel.
So it's like 1/2. No, it's not going to cancel. This is like 1/2. These 2, the one side is like 1/2. Because only coefficient, like one coefficient also is like 1/2. Is at the denominator. So 1/2 times 1/2, that's 1/4.
Oh yeah, that's true. I understand.
So you have 1/4 here. So as it be 1/2 each other, I'll just remove this.
And remove the 2 as well.
Yes, then I'll just remove these brackets. Since I
now put the x.
So I'll now put the x here at the numerator. And put 1 here. Currently taking it on the base first. Let me put 1 to me. Let me put 1 here. So then put the x here. Then let me remove the 2. and the bracket and the bracket. Are we good to this place?
Yes.
So now, this particular integral, what does it look like? Like the one we did.
Tan inverse.
Now look at
The
tan
other
inverse.
one, yes.
So our B in this case, first of all, I have to write this one in terms of something square.
Square, that's square root of 5 over 2 square.
That would be square root of
5 over 2
4
all squared.
all squared. But square root of 5 is what? Is still square root of 5. Abi?
Yes.
Or square root of 4 is what? 2.
2
So that's square root of 5 over 2 all squared.
squared.
So you are saying that 5 over 4 is square root of 5 over 2 all squared. But are you still with us? Is it clear? Can we move on?
Lumio.
Those kilos survive.
Yeah, I
Yes.
can hear you.
I hear you. Yeah, network is breaking. I don't know.
Let's hold on for her. Maybe she can hear us.
Tell me if you can hear me. So I'll guys go to square. Square root of 1 over 2. Because I put rational form here. So I'll put square root here. Square root of I've put the brackets here.
That's 5 over 2.
To be giving me unnecessary stress. So okay. So this one will be square root here. So square root of 5 over 2.
2. Mad. I said it seems interesting, Sha.
So the whole of these jargons now.
Is she with us now?
Yeah.
Yeah, she's with us. So
Okay.
this is gonna give us. So I'll remove this. Arctan. Arctan.
Tan inverse.
So the integral of this is now arctan. So first of all, let me put. That will be. So that will be tan inverse. So let me. This one will be minus 1. Tan inverse. Tan inverse x over a, abi? X over b. So our x is in this case x minus half. So first of all, let me put at.
Well, ability. Sorry. Don't you think we should put that 1 over 4 like outside and open another bracket so that we are still going to have another what's it called? Do you understand what I'm saying?
Oh, yeah, that's true. You're going to have 1 over b. Yes, you're going to have 1 over.
Yes, since we are still going to have 1 over b.
I get that's true. So 1 over 4 into bracket 1 over b. Our b in this case is root 5 over 2, abi?
Yes,
So,
yes.
Root 5 over 2. Arctan x minus half squared. So let's copy x minus half squared. So arctan over x minus half squared, I want to copy Jai. Okay. Arctan x minus half, sorry, remove without the square.
Not the square, yes.
X minus half all over root 5 over 2, abi?
Yes.
Okay. Then our final answer is just to multiply these two.
Mm-hmm. Which is with 5/2.
So that would be 25/8, Abby. Okay.
Wow. Wow.
So let me just remove this one. 25/8 upon this. And I can move this bracket that is here, and move this bracket that is here. Then you can try to simplify this one. So they add plus 6. And that's our solution. Let me stop the recording now. I'm done.